Good morning, students. Today we're going to do the continuation of the chapter Calorimetry. Okay. In the previous class, we have discussed about heat capacity and specific heat capacity. Today we're going to see the natural phenomena and some consequences of high specific heat capacity of water. In the previous class, we have said that the specific heat capacity of water is 4.2 joule per gram per Kelvin, or in the SI system it is 4,200 joule per kilogram per Kelvin, which means that 4.2 joule amount of heat energy is absorbed by 1 gram of water to increase or rise its temperature by 1 Kelvin. Okay, and in this case it means that 1 kilogram of water absorbed 4,200 joule amount of heat energy to increase its temperature by 1 Kelvin. Okay, so these are same. This is the mass is in gram and the mass is in kilogram. Okay, so the specific heat capacity of water is very high. So there are so many natural phenomena and consequences of high specific heat capacity of water, that is the advantages of water because of its high specific heat capacity. We are going to study them. We are going to study some of the consequences that happens in everyday life. Okay, number one is that the climate near the seashore is moderate. Number one consequence, the climate near the seashore is moderate. Or you may be asked, why is the climate near the seashore or in the coastal regions moderate? So to make the climate near the seashore or in the coastal regions moderate, there are two processes which occurs. They are sea breeze and land breeze. Okay, so these two processes, two phenomenon helps in moderating the climate near the seashore. So we will study how the sea breeze and land breeze are formed. First, let us study about sea breeze. All right, so let me explain to you. During daytime, the sun shines equally on the land mass and the water. Okay, but the land or the sand temperature rises more rapidly as compared to that of water. Why? Because the specific heat capacity of sand is much less than the water, and it is nearly about 5 times less than as that of water. Okay, so since the specific heat capacity of sand is less than that of water, the temperature of land or of the sand rises more rapidly as compared that of the water. Okay, so the air above the land becomes hot and it is light, and hence it rises up due to convection. In heat transfer by convection, we know that the lighter air or the warmer air, it always rises up. Okay, so the air above the land mass rises up since it is light. So there is a drop in pressure over the land mass, and to make up that drop in pressure, the cold air from the sea starts blowing towards the land. Okay, so it makes up the drop in pressure, and hence in this way this is known as sea breeze. When the cold air from the sea starts blowing towards the land, it is known as sea breeze. This process is known as sea breeze. And land breeze. Land breeze during night. Okay, what happens during night? The land mass and the water both radiate heat energy. all right? But the temperature of the land falls more rapidly as compared to that of water because water has a high specific heat capacity. So during night, the water is warmer than that of land. Okay, so the air above the water is warm and it is light, and hence the air goes upwards, or it rises up because it is light, and there is a drop of pressure over the water, and hence a cold air from the land starts blowing towards the sea to make up the drop in pressure, and hence there is a cold air which blows from the land to the sea during night time, and this process is known as land breeze. Okay, so these two processes helps in moderating the weather near the seashore or in the coastal regions. Okay, now number two consequence, or number two phenomena is hot water bottles are used for fermentation. Hot water bottles or bags are used for fermentation. Fermentation is heating the swollen parts of the body at a moderate temperature of about 50 degrees Celsius because it brings a lot of relief. Okay, so we use hot water bottles or bags for fermentation. Let us see what is the reason behind this. The reason of using water to cool the reason of using these hot water bottles or bags for fermentation is that because the water does not cool down quickly because it has a high specific heat capacity. Okay, since it does not cool down quickly, it can give out heat energy for a longer period of time. Okay, hence hot water bottles or bags are used for fermentation. Okay, and number three consequence is that water is used as an effective coolant. There may be question arising, why is water used as a coolant? Okay, we use water as a coolant in generators, in car radiators, in thermal power stations, etc. Okay, so water is used as coolant in generators, car radiators, thermal power stations, etc. Let us see what is the reason behind using water as a coolant. Okay, now when we allow water to flow through the pipe, through the pipes around the heated parts of a machine, okay, so the heat energy from such parts is removed, because the reason is that water, since it has a high specific heat capacity, it can absorb or it can extract a large amount of heat energy from the heated parts of the machine. Okay, since although it absorbs a large amount of heat energy from the heated parts of the machine, and the machine will cool down, but the temperature of the water itself will not rise so much, okay, since it has a high specific heat capacity, and hence we used water as a coolant. Okay, and number four, in cold countries, water is used as heat reservoir for wine and juice bottles to avoid their freezing. Number four. To avoid their freezing. Now, water is used as heat reservoir for wine and juice bottles to avoid their freezing. Okay, let us see why water is used. As we have seen that water, due to its high specific heat capacity, it can impart or it can give out a large amount of energy, heat energy, before reaching its freezing point. Okay, so it can keep the bottles, the wine bottles or the juice bottles warm for a longer period of time, and it can keep them warm. It will help them avoid from freezing, although the surroundings temperature falls. Okay, so it is used, water is used as a heat reservoir. And number 5, farmers fill their fields with water to protect their crops from frost. Farmers fill their fields with water to protect their crops. Now, on a cold winter night, okay, when the temperature falls down to about 0 degrees Celsius, what happens? The fine capillaries, the water in the fine capillaries of plants will freeze, okay? And when it freezes, the veins will burst because the volume increases when the water freezes, all right? So what will happen to the plant? The plant will die, and there will be a large destruction in the crops. So to prevent the destruction, farmers fill their fields with water, okay? When they fill their fields with water on a cold winter night, what happens? The water will keep the surrounding of the plants warm, since water has a high specific heat capacity, okay? Number 6, all plants and animals have a high content of water in their bodies. As we know, all plants and animals have nearly 70% to 90% of water in their bodies. We have in our body, we have around, all plants and animals have around 70% to 90% of water in our body, okay? So what is the reason of having water, that much percent of water in our body? Because since water has a high specific heat capacity, it helps in regulating the body temperature, which means that due to the high specific heat capacity of water, it maintains nearly the same temperature of the body in all seasons, okay? So the water helps us in various ways. So these are the 6 natural phenomenon or consequences of high specific heat capacity of water, or we can say these are the advantages of water in different fields, okay? So you may get questions like, why do farmers fill their fields with water? To protect the crops, like that, okay? So you have to learn each one of them. Now let us go to the next one, that is some examples of high and low heat capacity. we will see some examples of high and low heat capacity. Now, number one is that the base of a cooking pan is made thick. All right. Usually the base of the cooking pan is made thick. Let us see what is the reason. By making the base of the cooking pan thick, the heat capacity becomes large, due to which it gets heated slowly and it imparts or it gives out sufficient heat energy at a slow rate to the food for its proper cooking. Okay, so and even after cooking, because the base of the cooking pan is made thick, it keeps the food warm for a longer duration. Okay, and hence the base of a cooking pan is made thick. Number two is that the base of an electric press is made thick and heavy. Okay, electric press, we all know it is the one we use to iron our clothes. Okay, you will see that the base of an electric press is thick as well as it is heavy. What is the reason? Now, by making the base of the electric press thick, the heat capacity becomes high. The heat capacity of the base of the electric press becomes high. Okay, and since it becomes high, the heat capacity is high, it remains hot for a longer period of time even when the current is switched off. Okay, and hence it is made thick and heavy. All right, and number three, the vessel used for measurement of heat, that is calorimeter, is made of a thin sheet of copper. Calorimeter, or it is the vessel used for measuring heat, made of thin copper. Usually the calorimeter, as we have discussed, it is a vessel which is used for measuring heat, is made of a thin copper. Okay, it is made of a thin copper. In the last class we have said that copper, it has a low specific heat capacity. Copper has low specific heat capacity, isn't it? So since copper has a low specific heat capacity, and by making the vessel thin, the heat capacity of the vessel is low. Okay, and hence it will not take much amount of heat from the contents to increase its temperature. Okay, and hence the contents temperature, that is the mixture temperature, can be measured more accurately. Okay, so it is the copper, the calorimeter is made up of a thin copper, so that the specific, since the specific heat capacity of copper is low, and by making it thin, the heat capacity is low. Okay, so these are the different examples of high and low heat capacity. Okay, now let us go to the next one, which is change of phase or state. As you have learned, there are three states or three phases of matter. They are solid, liquid, and gas. There are three phase or state. Those are solid phase, liquid phase, and gas phase. Okay, so these are the three states or phase of matter. All right. Now, the same substance can exist in all the three phases under different conditions of temperatures and pressures. For example, ice at 0 degrees Celsius. Okay, when ice is heated at 0 degrees Celsius, what happens to the ice? It will melt and it will become water, which is in its liquid form. Okay, when ice solid is heated at 0 degrees Celsius, it will melt and it will be in its liquid form. Okay, when this water liquid is further heated, what happens? We will get vapor or in its gaseous state at 100 degrees Celsius. All right, so when it is further heated, we will get the water in its gaseous form at 100 degrees Celsius. So from this example, we can see that at different temperatures, water, the same substance, can exist in all the three phases or in all the three states. Okay, now what is change of state? When we say change of state, it is the process of change of one state or phase to another state or phase at a constant temperature. Okay, change of state or phase means the process of change of one state or phase to another state or phase at a constant temperature. Okay, and this change of state or change of phase is brought about by the exchange of heat. There are different processes of change of phase. We will study them one by one. Before that, let me draw here the different processes of change of state cycle. Okay, if we have matter solid, we have the liquid phase, and we have the gas phase. Okay, these are the three states of matter: solid, liquid, and gas. Now, if the change of state or the change of phase takes place from the solid to the liquid state, if there is a change from the solid state to the liquid state, we call this as melting. Okay, and the reverse process, that is the change from the liquid state to the solid state, it is known as freezing. Okay, now when the liquid state changes to the gaseous state, we call it as vaporization. All right, and when there is a change, the reverse of this, when there is a change from the gaseous state to the liquid state, we call it as condensation. All right, now when the solid state changes directly to the gaseous state, when the solid state changes directly to the gaseous state, it is known as sublimation. And the reverse of this, when the gaseous state changes directly to the solid state, it is known as solidification. Okay, so these are the different processes of change of state. All right, now let us study first. We will study melting or freezing. Melting and freezing. Okay, when we talk about melting, let us write down the definition. The process of change of solid state or phase to liquid state or phase at a constant temperature. At a constant temperature is known as melting. Okay, and freezing. Freezing is the reverse of this. The process, freezing is the process of change of liquid state to solid state. Freezing is from liquid, when there is a change from the liquid state to solid state at a constant temperature. Okay, it is known as freezing. All right, so here if we see in the melting, we can modify this one as this definition, the process of change of solid state to liquid state phase. In this case, there will be absorption of heat by the solid. Okay, so there will be absorption of heat. All right, so during melting, the solid will absorb heat and hence it will melt. And in the case of freezing, there will be liberation or rejection of heat. When the liquid state changes to a solid state, there will be rejection or liberation of heat at a constant temperature. All right, so now let us see for a pure substances. When we say pure substances, it means an element or a compound. Okay, so for a pure substance, the melting point and the freezing point of a substance is identical. Now when we talk about melting point and freezing point, melting point is the temperature at which the solid state changes to the liquid state. Okay, and freezing point is the temperature at which the liquid state changes to the solid state. So these are the two definitions of this. Now we said for a pure substance like an element or a compound, the freezing point and the melting point is same. Let us take one example. When we have ice is in the solid form. When ice at 0 degrees Celsius, okay, when we give heat, when ice at 0 degrees Celsius absorbs heat, what will happen? The ice will melt and we will get water which is in its liquid form. Okay, and this is also at the same temperature, 0 degrees Celsius. In this case, when there is melting of ice, the temperature will remain at 0 degrees Celsius until the whole ice melts. Okay, so the temperature remains constant at 0 degrees Celsius. And the temperature at which the ice melts is known as its melting point. And now if I take the reverse, when water liquid rejects heat, when water in its liquid form rejects or gives out heat, what will happen? The water will freeze and we will get ice. So it is at 0 degrees Celsius and this will also be 0 degrees Celsius. By liberation of heat, the water will start freezing at 0 degrees Celsius. It will remain at 0 degrees Celsius until the whole of the water freeze. Okay, so we have for this example water. Water, as we know, it is a compound. It is a pure substance. Water is a pure substance, and hence for pure substance the melting point and the freezing point is same. Okay, and number 2 thing you have to remember is that for a given mass of substance, the melting point for a given mass of substance, the amount of heat energy absorbed and rejected is the same. Okay, let me take one example. When we have 1 gram of water, when I have 1 gram of water, let me take ice, which is in the solid form. By absorption of heat, we know we will get 1 gram of water that is in its liquid form. Okay, so what happens when ice changes to the water form? There will be absorption of heat. Some certain amount of heat will be absorbed by ice. That amount of heat is 4.2 joule. Okay, 4.2 joule amount of heat will be absorbed by 1 gram of ice to increase its temperature by 1 Kelvin. But now let us say that the 1 gram of ice will absorb certain amount of heat energy to changes to its water form. So that same amount, this heat will be absorbed. Now, when there is a change from the water liquid state to the ice solid state, the same amount of heat will be rejected. Okay, the same amount of heat will be rejected. All right, so from this example we can see that for a given mass of substance, that is 1 gram, the amount of heat absorbed during melting and the amount of heat rejected during freezing will be the same. Okay, next we will see the heating curve of ice during melting. In order to find the curve, the heating curve of ice, let us do an experiment. You have to take a boiling test tube and we fill it with the ice chips. We take ice inside the tube and we insert a thermometer gently into the ice, taking care that the bulb of the thermometer does not touch the wall of the test tube. Okay, now we will note the temperature. When we take the temperature of the ice inside the test tube, it will be, the temperature will be 0 degrees Celsius. Okay, now the test tube which is filled with ice, we will warm it or we will keep it over a flame. Now when we keep it over a flame or if we put inside a hot water, what will happen? The ice will start melting, isn't it? Now we will take the temperature every half minute. We will take the temperature every half minute till it increases to 30 degrees Celsius. Now we will find the graph or the curve. That is, if we take y-axis as the temperature in degrees Celsius, okay, and if we take the x-axis as time in second, okay. Now this is 0 degrees Celsius or 0 time, and if we take the time interval as 30 seconds, 60, 90, 120, 150, 180 seconds, and so on. Okay. Now if we take the temperature as 10 degrees Celsius, 20, 30, 40, and so on. All right. Now this is the time measured and this is the temperature. We will see that when we take the ice, when we keep it over a flame, it will melt. So the temperature at 0 degrees Celsius will remain. It will remain at 0 degrees Celsius. Okay. Although you put a flame, although you put the test tube over a flame, the temperature, although heat is given to the ice, the temperature will remain at 0 degrees Celsius. Okay. Now, at 120 seconds, what will happen? There will be increase in the temperature. Okay. The temperature will start increasing. All right. And this temperature, 0 degrees Celsius, at this point, let me name it as A, B, and C. Okay. In the graph, AB, what happens to the temperature? The temperature remains constant at 0 degrees Celsius. All right, it remains at 0 degrees Celsius, and this ice, the ice that we heat, is melting at this point. So it will keep on melting, but without the increase in temperature. All right. As soon as it reaches this point, at a certain time, that is 120 seconds, the temperature will start on increasing. Okay. Which means that at this point, AB, the ice keeps on melting. It will keep on melting until the whole of the ice melts. There will be no increase in the temperature. It will remain at 0 degrees Celsius. Now only after the whole ice melts, the temperature will start increasing. All right. So this 0 degrees Celsius is known as the melting point of ice. Okay, it is known as melting point of ice. So you may be thinking, why we give heat energy? Heat energy is supplied to the ice. Now the heat energy in this portion, the heat energy which is supplied to the ice is used up for melting the ice in this position. Okay, now after that, the heat energy which is supplied after the whole ice melts, the heat energy which is supplied is used up to increase its temperature after the whole ice melts. Okay, so this is the heating curve. This is heating curve of ice, and this is very important. Okay. Now let us see the change in volume on melting. On melting, certain substances like lead, wax, etc. expand on melting. Examples, substances like lead, wax, etc. expands on melting. Okay, but substance like water, it contracts on melting. Contracts on melting. All right, which means that lead, wax, when it melts, its volume increases. But water, on the other hand, when it melts, the volume decreases. Okay, let us see. For example, if 1 gram of solid wax, if 1 gram of solid wax has volume 1.161 centimeter cube. All right, and when we melt on melting at 64 degrees Celsius, when we melt a solid wax which has volume 1.161 centimeter cube, the volume will become, we will have a molten wax of volume 1.166 centimeter cube. So we say that when wax is in its solid form, okay, we have a volume which is equal to 1.161 centimeter cube. Now when we melt the solid wax in its molten form, we have a volume which is equal to 1.166 centimeter cube, which is more than this. So we can say that this substance, the wax, expands on melting, since the volume increases on melting. Okay, another example is water. If we take 1 gram of ice which has volume equal to 1.091 centimeter cube. Okay, when we have ice, the solid form, 1 gram of ice which has volume 1.091 centimeter cube. Now when we melt this ice at 0 degrees Celsius, when ice is melted at 0 degrees Celsius, we will get water that is in its liquid form, and it has volume 1 centimeter cube. All right, so you can see that here, after melting the ice, what happens to the volume? The volume decreases to 1 centimeter cube. So we can say that water contracts on melting. Okay, so from these two examples, we see that there is a change in volume on melting. Some substances expands or it increases in the volume after melting, whereas water contracts or the volume decreases on melting. Okay, so there is a change in its volume. All right. Okay, so this is all for today's class. Now you can ask me if you have any questions regarding this. Any questions? Any doubts? Okay, I hope you don't have any doubts. I hope it's all clear. So I will stop my class for today. Thank you.